Hi, I'm going to do a video about the theory of plate tectonics. This is from your textbook from PearsonRealize.com, 2017. I'm going to use in the video the phrase AKA, which means also known as. The first thing I'm going to talk to you about is the Earth's lithosphere, AKA its solid outer shell. The lithosphere is cracked like a broken eggshell. The pieces are separated by cracks. The pieces are called plates. Plate tectonics is the theory that started in the mid-1900s that combined the ideas that plates can converge, which is they can come together. Let me show you that. Here's an example of converge, where we have this red block and this blue block, and notice the arrows are pointing that they're coming together. Converge. Plates can also diverge, which means to move apart. Let me show you that in a picture. Here's the red and the blue block again, but now notice the arrows are pointing away from each other to diverge. Plates can slip past one another. That's called a transform boundaries. Here's the picture to show that. Here's the red and the blue box again. But notice one arrow's going up and the other one's slipping down. The other part of this plate tectonics theory is that seafloor is spreading in certain areas. And that's what's causing the Earth to be dynamic in movement. What's causing this dynamic movement is the convection currents, which is inside the Earth. There are 3 points I'm going to make, and there's going to be a picture. Let's do one at a time. Convection currents are in constant motion in the mantle. Earth's plates are on top of the mantle. The plates are in slow, constant motion driven by the convection currents in the mantle. Those points are going to be demonstrated in this model here that I have that I'd like you to draw. Here we have a picture of the Earth, and we have 3 different layers. We also have temperature written in here. The temperature for this top layer here is 1,200 degrees Celsius. Then we have, and I colored it in yellow, the temperature is 5,000 degrees Celsius. Then we have our final inner core, which is the temperature is 5,500 degrees Celsius. Let me take the camera and so I can pull it in so you can have a nice closer look at it. And here might be a good time for you to pause the video so you're able to take a picture and copy it into your notebook. Notice that I added details. This is continental land masses. Here's some water. I'm drawing some lava coming up. The continentals are drifting apart, which is an example of the plates diverging. Here's the convection currents that are happening inside of the mantle. And then I have labeled, and I put this one in orange so you can see the difference, the mantle, the outer core, and the inner core. Another piece of information that I'd like for you to have is about the plate motion over time. Subduction is gravity pulls the denser plates downward into the mantle. Another note about subduction is plates move slowly from about 1 to 12 centimeters per year. The last note about subduction is Earth's plates can carry the ocean floor, continents, or continents and oceans together. Your last note that you need is about plate boundaries. The first note is about faults. Faults are breaks in the Earth's crust where rocks have slipped past each other. They form along plate boundaries. This plate boundaries and the combination of the convection currents is how you have plate movement. Plate movement produces changes in Earth's surface and the ocean floor, such as formation of volcanoes, mountain ranges, and deep ocean trenches. Thank you for taking the notes, and I hope you had an easy time. If you have any questions, please make sure you ask me in class. Thank you.